Okay, let's go ahead and look at our hurricane activity from yesterday that we have been working on. So when we look here, you should have gone to this site using Internet Explorer and dragged this little red hurricane to the different spots in order to figure out where hurricanes could form and where hurricanes haven't been able to form. So if you haven't done that, pause the video, go to this site right here, put your X's, and you can kind of see mine as a sample. And then I want to know, why do you think that the hurricanes formed where they did? Please pause it, do the activity, and then come back to that. Okay, so at this point, you should have pressed play, hopefully, and you have done this little part, and you saw that in this region right here, we can't have hurricanes, and this region, we can. So down here is where they form, here's where they thrive, like they do really, really well. And then here is where they start to weaken, like you saw in the little interactive. So you should have answered, why do you think that the hurricanes form where they did? And what you probably noticed was that these up here are going to be in colder water because they're further away from the equator. And remember that the equator gets the most direct sunlight, so therefore the water is going to be warmer. And we'll talk about ocean currents and things like that in our next unit. Let's go ahead and look at the data on the next ones. So right now it says the dots show where hurricanes start. So you can see on mine these little red dots. These are the pathways that they follow, those lines. And I want you to take a minute and pause and notice, where do all the hurricanes start? Okay. Once you have written something, go ahead and press play. So when we look at this one, we notice hurricanes start in the ocean. Okay, so then the question is, why do you think they start in the ocean? So if you look here, notice they don't ever start on land. So why do they start in the ocean? Okay, write your idea here and then press play when you're ready. Okay, so more than likely what we talked about in class is that the hurricanes need the moist or wet air above the ocean. Okay, but then what's interesting is this question here. If you look, this is the Atlantic Ocean. This is where a lot of them are going to form and thrive. But over here in the Pacific Ocean, right here by Washington and Oregon, right up here, there aren't any hurricanes forming there. So I want you to think about why. Why do you think, based on what we've studied about pressure areas, why would they not be in the Pacific Ocean by Washington and Oregon? Okay. If you said something about the ocean water is not as warm, you are accurate. So remember that the equator is going to be down here. And so when we look about this area here, it's far enough from the equator that we're not going to have many hurricanes form. So here's the equator, okay? When you're looking at where these are forming, you're looking here at this area right here, okay, in this yellow area. Up here in these green, there's not trade winds, which we talked about global winds, and it's in a cooler area, okay? So when we look at where they are located, they're not located up here because the air is just too, the ocean, is just too cool. And then right here is where that equator is. And these are those low pressure areas from having higher temperatures. Because remember, the higher the temperature, the lower the pressure. Okay, let's go ahead and continue looking at our next chart. So now you've got a whole bunch of graphs. And when you look at them right now, you'll notice that mine are colored, yours are not, and that's okay. This is June, and the blue on mine means it's likely to have a hurricane. Green is more likely, and orange means it's most likely to have a hurricane in that region. So based on this is June, July, August, September, October, and November. Pause the video and write which months, based on the graphs, are hurricanes most likely to occur. Okay, once you have written your answer, because remember, you need to make sure you're predicting first, then go ahead and press play. Okay, if you said they occur the most in August, September, and October, you were correct. Okay, to look at this from another angle, okay, from another type of graph, if we look at this graph here, we can see that August, September, and October have the highest number of hurricanes. But what's weird about that is that when I think of it starting to get warm, it's June and July. So if a hurricane needs warm water, okay, a low pressure area, in order to exist, why is it that these two right here in June and July, they don't have many hurricanes? Make your prediction here and then press play when you're ready. Okay, so what I want you to think about is that idea of what we talked about with sea breezes and land breezes. Remember that at night, the water is going to be warmer than the land, creating a land breeze. And the reason it is warmer at night is because water, and then during the day the water's cooler, that's because water takes longer to heat up and water takes longer to cool down. So in June and July, the water is heating up. In order for a hurricane to form, the surface temperatures of the water need to be about 80 degrees Fahrenheit. Okay? They're not going to get to 80 degrees Fahrenheit right away because it needs to warm up. So it's warming up in June and July. Then by August, September, and October, it's warmer. By November, it's starting to cool off. So the hurricanes are going to die down a little bit. Hurricane season is June 1st to November 30th. However, they're most common in August, September, and October. Now, the interesting thing that we talked about in class is that a hurricane does not just pop out of nowhere. So when we have tornado warnings, tornadoes kind of occur pretty quickly and then they're done. Hurricanes don't. They're going to grow and then they're going to be there for quite a while. So before I go over this part here, we're going to go ahead and we're going to look at this bottom graph right here. So the first stage in a hurricane development is going to be a thunderstorm, which sometimes is called a tropical wave, which is sometimes called a tropical disturbance. Okay, then they might progress, some might just die down and then they never go to stage 2 and turn into a tropical depression. After a tropical depression, if they don't die down, and we're going to see what the characteristic is that makes them become the next stage, they'll become a tropical storm. And then only a small percentage, about 1%, will become a hurricane. So when you look at this little chart right here, I want you to look at it closely, and I want to know what is the difference between the first stage, thunderstorm, tropical wave, disturbance, the second stage, tropical depression, third, and the fourth stage. Okay, pause the video. Okay, if you said the wind speeds are different, you were correct. So a hurricane, in order to be a hurricane, it has to be 74 miles per hour or bigger. Okay, that would be a stage 1 of a hurricane. Okay, but in order to move up from the tropical wave / tropical disturbance to a depression, you're going to have an increase in wind speed. It's going to get stronger. And remember that wind speed picks up based on our tornado simulator activity where you change the air pressure. And the pressure difference is bigger, the speed of the wind is going to be faster and stronger. In order to be a tropical storm, it has to be 39 to 73 miles per hour. And in order to be a hurricane, it has to be 74 miles per hour. Okay? So let's go ahead and jump back up to the top part where it asks about this little graph here. I know this is a little hard to see, but these are all the hurricanes that have hit the United States. Okay, and the question I asked is true or false? Hurricanes occur equally in all states. Well, that's going to be false because you're going to have more hurricanes when you are in this region, in the southeast region. You're not going to have any hurricanes here in the Midwest where we live because it's just too far away from the water. Here's Andrew, the one that destroyed my house in 6th grade. Hurricane Andrew's right there. It was red, which was a Category 5, the biggest category distinction you can get. And then notice it's again over here because it crossed here and then got more warm water from the Gulf of Mexico and then hit again to the United States. It was pretty devastating. Okay, so when we look at this, I want to go through the parts and what causes it. So try these 2 lines by yourself. Pause the video, make sure you're trying them because you need to know these about how wind moves and about pressure differences. And we're going to look at these. Go ahead and press play. Remember that wind moves from high pressure to low pressure. And remember that the higher the temperature, it's an indirect relationship, the lower the pressure. The bigger the difference in pressure, so the difference in that pressure, if it's bigger, you're going to have stronger winds. If it's smaller, you're going to have weaker winds. So let's look at this. If I have warm, very, very warm ocean water, 80 degrees or warmer, that's going to cause very low pressure. The winds always will blow toward, not away from the low pressure area. And the low pressure area of the storm is called the eye. And in that area, there'd be very little wind and very little rain. Winds will keep blowing toward the eye and eventually hit the eye wall. Then those winds are going to continue to feed the hurricane, and those winds on the outer part are called rain bands. Sometimes they're called wind bands, and sometimes they're called bands of wind or band of rain. So here's an example of the parts of a hurricane. In the middle, we have the eye, and over here, this is supposed to kind of be pointing here, okay, that's going to be the eye wall, which is the worst part of the storm because that's where all the wind is kind of hitting each other and circling around. And these are our rain bands. So when we look at a hurricane like this, here's the eye. This part right here is the eye wall. And this part here are the rain bands or the bands of rain or the wind bands or bands of wind. Okay, so as we're thinking on hurricanes, remember that hurricanes are going to last much longer, and the reason this is so big is because the storm is much larger. Remember that a tornado also has a low pressure area in the middle, but a tornado is a much smaller storm, so it doesn't have as big a low pressure area like you see with the eye right here. The bigger the pressure difference, the warmer the ocean, the higher the temperature, the lower the pressure, therefore causing a larger storm. So as we're thinking on hurricanes, it's important to know how they form. It's important to know why they form. And it's also important to think about how this relates to climate change and global warming as we move on to human impacts. So at this point, double check over your work. Make sure that you have filled everything in. And make sure if you have any questions that you see me. Nice work.